Okay, doing a little bit of review of parametrics. So this parametric equation has got an x equation and a y equation. And I'm going to make the x equation 3t plus 1. I'm going to make the y equation t squared plus 4t. That means that instead of just taking a normal x and y graph, it's almost like I graph two different things, but at the same time. So we don't just need an x-y graph, we need the time at that point. So give us an example. What's one point that's at a certain time? Tell me what to do. Okay, all right, take it. Plug in 0 for t, okay. If I put in time 0 at time 0, keep going. So x would be equal to 1 because I put a 0 in here and I get 3 to 1. Awesome, okay. And then y would be equal to 0 because I stuck a 0 in for the time and I got 0. Okay, so at 1 comma 0 I should put a dot, but I should also say something. That's t equals 0. If you haven't been doing this, you're going to be losing points on the test. You can't just have, here's my graph. You have to say, here's time 0, here's time 1, here's time 2. And that again gives you your element of like direction for it. Okay? So would you please find and graph 2 more points on this graph? And I'm going to pause for a minute while you try that. So for this, we'll say that we're going to do from between 0 and 4. But that doesn't mean you have to do all the points in between. But logical points to do would be the beginning and the end. All right, I'll pause again while you give that a shot. I did need a limit for my time. Right. So what did you get for a couple points besides 0, 1, 0? Raise your hand if you got 1, 4, 5 in your mix. Okay, good. Next one. Raise your hand if you followed that as well. Okay, good. And what's another logical point we have to have? Yes, sir. 4. And 4 would give me what? X is what? And the other ones? There we go. And I usually say you need 4 points. So there's 4 points. Do you have to like skip one course? Now you could have done 3, but I'm only going to check that you have 4 points. I strongly encourage you to have both endpoints because if you don't, you will lose points. Why? Because you have to grade it from here to there. That's a really important topic here. Is this isn't just a graph that you can kind of graph part of and slap arrows on the ends of. This is a graph that goes specifically from one point to another. And it goes from time 0 to time 4. It's like a 4-second long experiment. Okay. Any questions? All right. So if it started here and it ended at time 4, it was at 13, 32. It's really tough to see exactly where that would be. But do you get, because of that squared in there, there's got to be sort of a parabolic element to this? Does that make sense? Do you get if there had not been a squared here and they had just been t's? What would you have had? A straight line. All right. And that brings up a topic from the other day. Do you remember if you just have a dot here and a dot here, and let's say this one's at 2, 10, and this one's at 8, 14, do you know how to give the equation for a line segment with direction? It would be from here to there. Do you get it's like a line going through 2 points? Does that make sense to you? It's just like a line going through 2 points, except it only goes from here to there. These, of course, what kind of equations? There's the P. Parametric equations. All right, so you need an x and a y. Now I know we did this the other day, but I know this one's a little obscure, and we only did it for like 2 seconds. And if you didn't do your homework especially, you wouldn't have practiced it, and therefore it didn't set in your long-term memory. So how many of you think you know how to do this? Be honest. Well, it's like half of you. That's not too bad. Okay. Am I willing to try to explain it to somebody? Come on. If you think you know what it is, just give it a shot. I'm not going to mock you if you're wrong. Yes? So you start with 2 because it started there. That makes sense.
And it goes up 6, and you do plus 6.
Went up 6 to get to there, so plus 6. T. Why do we have that T in there? There you go. To be a parametric, it has to have a T in there. That's a good answer. What will a T do for us? That gives us the first new point, and then we could put in time 2 and get the next new point, and then time 3 and get the next new point. All right, do you get how this is a lot like this equation? Do you remember back to algebra when you had these? What was that called? And what was that called? The y-intercept. Okay, and it's the b also, yes. And do you get this is kind of like that? It's got your starting place. You know how you always started at the y-intercept, and then you went up and over with this? This has got your starting place, and it tells you how far up or down to go. It's a lot like that. So it's pretty much a little point slope, y equals mx plus b form equation. Okay, so there we go. And if you got that one for x, then all of you should be able to get the y one. I'm going to roll the dice and see who to call on to ask for that. Because even if you didn't get it before, from that explanation, you should be able to do the y one. It's just like it. No. Row 5. Last person. Is it just t? It is not. Think of it this way. There's a starting value for y just like there was for x. The last 2 numbers we just used were the 2 and the 8. I don't know if you noticed that. So do that same kind of a process with the 10 and the 14. You got it. Raise your hand if you had that one right. Ooh, a lot of people did. Okay, good. Okay, now what does a parametric need? One more thing. Domain. So time is between, well, in this case, we get to pick it, and I always want you to pick it as 0 for your start, because you got to get used to that idea that in general, we use time equals 0 as your starting value. And then you could pick this as any arbitrary number. I strongly recommend you keep it simple, and you say between 0 and 1. Now, I want to know if that actually works. Does it actually create a line that goes from there to there? How could you tell? Graph it. Use your graphing calculator. Put this in to your graphing calculator and see if it really creates a directed line segment that goes from about 2, 10 to 8, 14. I want to warn you on this. Your window is going to be off. If you do zoom 0, that's a really nice zoom that zooms you to fit your graph. It's called zoom fit. I'd use zoom 0. I'll pause for a second while you give this a try. All right, here we go. Kids got this to work on their calculator, and it's probably the most boring graph in the world. This was not it. Mine's a little different than yours. But I want to get into some more cool graphs, and that's, in fact, the intro to your lab that we have. So the lab, I know sometimes labs are painful, but this is just an easy one. It's relatively speaking frolicking through the meadow with daisies and ponies and maybe even a unicorn. So you're going to be taking your calculator and playing around with fun things that make cool patterns. So for right now, I'd like you to find the one in our notes, which has the lab right here. Nope, that's the worst one ever. This one. Find the one that says 5.9 sine. And this one gives you an idea of some of the fun pictures that you can do. I'm going to do 5.9 sine of 2t and 8 cosine of t and see what the graph looks like?
Yeah.
You have that slide. You sure?
Yeah.
Okay, oh, I remember. I had you guys upload this, and then the next day he added this slide. Okay, so that's all right. You don't have to have the slide. Look up at the board. You can actually tilt your head sort of upwards a little bit, and then it's right up here. All right, so I'd like you to put in 5.9 sine, and again, does it have to be 5.9? Of course not. We're playing around with stuff here. So 5.9 sine of maybe 2t would be a way to start. For all these, just make your team end 0, unless you find that it gives you a really cool effect to make your team end something else. Because in the end, you're more like an artist on these than you have been in the past. I'm zoomed in a little too far to really appreciate this thing, so I'm going to zoom out. This is something you wouldn't have seen before. Look at that. It's like a planet in orbit. All right. So that was that graph with this window, 0 to 10 with steps of 0.1. Now, what if I made my steps bigger? Would that make a difference? Let's find out. I want to make my steps be steps of 1. That's 10 times bigger steps. I bet it's going to make a big difference. Not quite as pretty, is it? Exactly. So obviously you can make a big difference in these just by changing some of the settings. But you can even make a bigger difference by trying different variables, or sorry, different coefficients in front of your t. And this is just, I want you to play with it and get a feeling for what happens when you do this. And that's what you have to write up. So you make, I know the glab says 4, I'm cutting it down to 3. You're making me 3 cool pictures. That is not a cool picture. That just looks like a child scribbling. Okay, so that would not count. I mean, I would not give you points for that. So make me 3 really cool pictures. Anybody got one right now on their screen? All right, so tell me what you did. He has the copyright on this, by the way. Go ahead. Cosine t. Cosine t. The y is what? Sine 2t. Interesting. So that one just doesn't look too cool yet, but go ahead. You zoomed in. Okay, so I'm going zoom in. Okay, and then I bet my steps are way different than yours. What steps you got? Okay, that's 220, or no, that's pi over 24. So I'm going to use steps of 0.1 just to see what happens. And again, if you got a graph that you think is cool, play with it and make it, maybe you can make it even cooler when you add in a few more steps to the graph. Yeah, that's pretty cool. All right, and if I do zoom square, it'll also help make things a little more symmetrical. Sort of like butterfly wings now. All right. So you find 4 things. Then once you've got, I probably need to zoom in a bit on that one. Once you've got something you think is pretty cool, then take a picture of it using your iPad Mine disappeared now. I'm going to do zoom 0. I bet it'll make it pretty cool. Oh, there we go. Awesome. Yeah, I like that one a lot. Okay, so once you've got one that you think is pretty cool like this, you take a picture of it with your iPad, and you got one of your 3 cool graphs done. Then word to the wise, so that you don't have to like scramble to try to replicate it. Just take a picture of the screen that's got the equations on it, and then maybe you want to take a picture of the window too, because all of those things matter on how to make it as cool as possible. Okay? If you just have a picture of the graph, you will lose points, because in the calculations section, remember on the format for all labs, which we are using again, the purpose is, it says it right on the screen. Okay, you can find the purpose. But the pictures, the graphs are going to be worth more points this time, because obviously it's a graphing lab. Okay, so you need to have good pictures. Then the procedures part is what you did, and the calculations part, calculations is where you actually have these. This is your calculations. It's the actual equations you used. And again, I'd accept a picture right off your calculator of your equations and your window. Okay? All right, so that's the lab. When's it due? Friday. Friday of this week. You know that if we're too busy Friday, I won't correct it Friday. But be ready for Friday, because that's when first day I could correct it. Yes?
Should we just put it on this side, the top or the graph side?
I don't care where you put it, as long as you have the format for all labs, as in it needs a conclusion and reflections. It needs procedures, which is what I did. It needs calculations, which are, see what I'm saying? You need the format for all labs. Got a cool one? All right, what do you got? Tell me quick. It's all right, doesn't have to be the coolest thing in the world. I'd like to show another example.
Put your window first as
All right.
for x negative 2.5.
For the t, you mean? Oh, x min. Negative 2.5. Okay.
Positive 2.5.
For the max. Okay.
And then same thing for the y.
Negative 2.5. Positive 2.5. Okay.
Put
T.
T max at 100.
Ah. Definitely something we haven't tried before. Okay, now what's the actual equations?
4 sine 12 over 13.
What on earth made you want to do 12 over 13?
T.
All right.
And then 3 sine
3 sine t. Okay, my window. Are you sure you want that window?
My windows have to go a lot. Okay.
I'm going to do a zoom 6, or a zoom 0 to try to make it fit. And I'm going to break it because it's still going. So I'm going to go zoom 0. Come on, baby. Work. Show me a cool graph. Congratulations, you broke the calculator. I've never had anybody tell me an equation to type in that kills my calculator before. Did you look that up on the internet? Equation to destroy calculator? All right, I'm going to trust you that it comes out really cool, but unfortunately nobody at home is going to be able to see that. So that's the lab, and make sure that you've got the format for all labs followed. All right, last thing, your little review session here. So I'm going to try to summarize everything you've learned so far and see if you're good at it, kind of get a little formative assessment on where you're at, okay? So put the calculators away. Put them away, otherwise I know you're going to be tempted to play around with and find cool things. Feel free to do that in your science class when it gets boring. All right. So now you're going to be doing a little bit of a review. Act like we're on the test right now, okay? Which is, by the way, not tomorrow, but the next day. Yes, it is. Yeah, it is. All right. I know. Changed my mind. It's too easy. All right. So it's not tomorrow, which is Tuesday. It's the next day. It's Wednesday. You could have it tomorrow. It wouldn't be that hard. I mean, this is one of the easier tests. All right, so here's a set of two equations. Okay. First of all, what's it missing? It's not called the limit. The domain for what? T, all right, I'll give you that. Let's say that the domain for T goes like this. Then make this into a equation that is not parametric. You got to get the T out of there. Remember, the equation that is not parametric does not need to be solved for y or x. And leave it in the form in which it comes out. It'll save you a ton of time. I'm going to pause for a second while you give that a shot. If you think you have it, turn it my way, and I'll grade them for you and tell you if I think you got it. Okay, my reporting was paused for a second there while I wrote this new problem out. Here's another problem where we're taking something that is not parametric and making it into a parametric equation. When you're done with this one, compare with the student that I paired you with and see if you end up getting the same set of an x equation and a y equation and a domain for t. All right, so you should have made me two equations. And the first one's really easy. It's the y equation because I rewrite this y equation as y equals 2t squared plus 3t plus 1. Now I got the t into my system. And all I did was swap out x as t, and then that's what you write. X equals t. Raise your hand if you had those two. Awesome. And then to take this one more step and have my t domain, I have to look and say if x is t, then x is t, and then 0 and 2 would be my domain. Raise your hand if you had that perfect. Okay, good. Next topic. If you had to take a point that had, make points for a parametric that had this, why isn't t time anymore? So it's an angle. So then if you were going to give me a t domain, what's a typical domain like for something like this? 0 to 2 pi would be good, or 0 and 2 pi is kind of strange because it actually it like ends the exact same way as it begins, which is kind of cool, but it overlaps it, so maybe I could go like this. Okay. Given that graph, I'd like you to find me just 2 points on the TXY chart. Use 0, and let's just have you use pi. I'll pause for a second while you give that a shot. Okay, so if I put in 0, did you get sine of 0 and cosine of 0 giving your x and y point? What is sine of 0? What is 0? It's 0 degrees. So if this is like a 0 degree angle, it's not opened up at all. It hasn't like opened up to there. It's still at 0. Then this point is 1 comma 0. And sine is y. And so y is 1. And so your x is 1. Cosine is the x. Nope, I did that wrong. Sorry. Y. Sine is y. Y is 0. And therefore, this right here is 0, and it's 0, comma 1. Raise your hand if you had that one right. Okay, good. Then, give me the pi one. 0, negative 1. Awesome. Now, if you were to actually do this on a parametric graph, I'd like you to see it. So everybody do this. You know how to put this in now. Use your graphing calculator. I know I told you to put it away, but take it back out again. Do one more. But limit it to between 0 and 2 pi. Now, if you think about that, where it starts and where it ends, I'll pause for a second. Let me give that a shot. Okay, you guys get kind of an egg shape. You didn't? Oh, it's probably because my window's weird. Okay, I'll make my window, I'll do zoom box. And the box makes it, or the zoom square. All right, it's still kind of egg-shaped, though. It's not, do you guys see that, like, did you do zoom square?
Yeah.
Well, I guess it, okay. You're right that it looks like a circle. I agree. What I'm trying to get at is, like, look at how it's numbered here. It's hitting at 1, and here it's hitting at less than 1, isn't it? All right. That has to do with what is x and what is y. X and y are based on t, which is this angle. So I can't explain to you why this doesn't look, that it looks like a circle where I think it should look like an egg. But anyway, it's okay. These parametric equations get really weird, and you'll explore them a little bit more with your lab. Remember, when's the lab due? All right. Last thing is to tell you what your homework is for tonight, and this is important. Your homework for tonight, everybody look at the file. And some of you guys, I'm going to start grading homework more often because some of you guys are really slacking on it, and I want it to hurt bad. You betcha. So, here's our 5 questions, things you need to know for your next test. You need to make me 1 question for each, and then go to the next page and give the answer to your question. So, like, for instance, you got to make me one that's rectangular, and the job is to make it into a parametric. You have to make questions that then other kids in class are going to answer. Okay? Don't have to make them perfect. Just have to make, here's a rectangular equation, y equals 3x plus 7. And they have to make it into a parametric. Okay? You make the problem and you make the answer. But wait, there's a little bit more. This is 1 review question on changing parametric form, changing to parametric form. It's just really simple. We already practiced it, but I'll have you do 1 more at home. And then 1 more like this, which is that directed line segment thing, where you have 2 points, and you have to go from this point to that point. Do you remember? I'll give you an example. 2, 5 turning into 10, 12. Right? Did we do that in class? Did we do this? All right, so then you, oh yeah, that's right. You were even doing it. So your x would be 2 plus, and then this one went up by 8, so it's 8t, like that. Okay, so you're making a directed line segment for the purple slide. So you end on the purple slide, and then that's it. Make sure your questions are of good quality. We're not leaving yet, by the way. It's still like 4 minutes left, but anyway. Okay, you can stand by the door. Yes, you can go to the bathroom, but you have to come back. All right. So end on the purple slide, and that's your homework for tonight. That's all I got for the